All right, good afternoon, 8th grade. It's time to get going. Did you hear the bell? Lunch is over, right? We'll give everybody a few minutes to join us. But right now, I want you guys, once you join, I want you to take a look at the goal. We're multiplying and dividing with scientific notation to answer questions about animals, careers, and planets. The tasks that we focus on today are going to be about careers. You'll see that in activity 4 of lesson 14. We're still working on our EE standards, scientific notation. We're going to do the warm-up. We're going to do a recap of exponential rules. After that, we're going to do task 1 and task 4 of lesson 14. And then I got a couple of assignments for you. If you guys have questions, you should be able to ask the questions right there in chat. All right, this current stream is for 8th grade, periods 6, 7. For the 6th grade streams, just look on your Google Classroom. All right, 8th grade, I need you guys to write down your warm-up, okay? Because I'm going to zoom out and start working this out with you guys. 2 equations to solve, just like we did in class. (200 equals 16 times the quantity of 6x minus 3. And then number 2, I need you to solve 1,290 equals a tenth of x added to a fifth of x. All right, write those down. And I need you guys to try to solve those. What stuff do you need, Dagny? Oh, the workbook and everything, notebook, stuff like that. All right, get what you need. Get what you need. I need you to give you guys some time to do this anyway. And if you are ever looking at this after the stream is done, just pause the video whenever you need to, just like you do on your regular stuff. All right. I think you guys should be able to see that. We're actually going to solve both of these 2 different ways. So I want you to focus on what strategy you're using and be able to compare it. And if you really don't have a strategy, it's time for you to start picking one, right? Because we've been doing these for a while. I want you to see what you're comfortable with. And then just practice it over and over again, and you'll get good at it. All right, let's get started. There's a couple ways that you can start. You guys seem to be pretty comfortable with distributing, so I guess that'll be the first way we start. If you choose to distribute first, then you're going to multiply 16 times 6x, and then 16 times -3. So we'll leave 200 alone. And 16 times 6x should be 96x. Correct me if I'm wrong on any of this, just chat. And then 16 times a -3 should be a -48. All right, next step. This is where things start to look very similar as to other strategies. I could hear you guys telling me add 48. We'll add 48 to both sides. That would give me 248 is equal to 96x, and nothing left there, right? 48 minus 48 is 0. And then next step. Next step, opposite or inverse of multiplication is to divide. So you should tell me divide by 96. Now, for those of you using calculators, you're probably getting a decimal. And I'm gonna show you that more so in the other way to solve. But for this one, let's simplify the fraction. Let's keep the answer in fraction form, and let's just simplify. And what I mean by simplify is if you take 248 and you divide it by 8, and you do the same thing to 96, you should get 31 over 12. Let me know if you get something different. Hey, Elijah, I'm so glad that you joined. I hope you have your notebook and your workbook, all right? If not, grab them real quick so you can take good notes. And if you guys have any questions, you just let me know, okay? All right, I'm going to leave this up here for just a minute. Hey, Thais, great. All right. Starting to feel like class, right? Like I said, I'm gonna leave this up here for a minute. If you guys have questions about this strategy, we distributed first if you're just joining us. And every step is up there so far. But I would like to show you a second way because you didn't have to distribute first. How you doing, Ivan? All right, let me mark you guys down. Ooh, yes. I'm not sure if you can pick it up at school. You can try, Elijah, because you're going to need the book. If you can't get in today, try tomorrow, but I need you to try to get your book back, okay? Also, it's actually online, so maybe you don't need your book. Just go to openupresources.org like we would in class. And this warm-up is not in your book, right? So this you would put down on paper. But the activities we do, when we do 14.1 and 14.4, those are actually in your book. So you can, if you don't have the book, just look on online. We are in Unit 7, and we're going to be looking at Lesson 14 today. So Unit 7, Lesson 14. But that's after the warm-up and the recap. No problem. No problem at all. Okay. So let me show you the other way. So if you didn't write it all down, it's okay. I'm going to be posting this video on our classroom stream, and you'll be able to look back at the video, pause it, rewind it, whatever you need to do. All right, so I'm going to erase this part so far because I'm going to start this problem again differently, and you pick the way that you're more comfortable with. All right, so we're going to get rid of that. And we're going to get rid of all of that. Okay. Now, what I want you to start looking at, I want you to start really analyzing these problems. The way you could have also started this is technically, since these two are connected by multiplication, you can start off just by dividing everything by 16. I could divide by 16 there, and I can divide by 16 there. And if you do that, this obviously 16 divided by 16 is 1. So you have 6x minus 3 is equal to, and if you do 200 divided by 16, you should get 12.5. If you don't get 12.5, let me know. And now you see how it looks a lot like before, where you're going to add to both sides. Now be careful here because this is a decimal, and I don't want you to put the 3 over here. This 3 is a whole number, and over here the 12 is a whole number. So it's plus 3 and plus 3, because technically this is 3.0, right? 3.0, whole number. All right, so that will make that 15.5, and this is just 6x. Now this is where I'm thinking you're gonna, like before, if you were using your calculator, now you'll get a decimal answer, or a decimal equivalent to what we had before. Remember what we had before? It was x equals 31 over 12. All right, now watch this. So we do keep the same rules that we've been doing, right? Divide by 6, inverse operation. Divide by 6, divide by 6. So x equals 15.5 divided by 6, and you should get 2.58, and then the 3 is repeating, if you did that in your calculator. Now, we just picked different strategies. So we're supposed to get the same answer. Well, in your calculator, what's 31 divided by 12? 31 divided by 12. Type that first, divided by, and then 12. And you should actually get the same exact number. 2.58 with the 3 repeating. 3, 3, 3, 3, 3 over and over again. Let me know if you guys are getting something different or if you have any questions. But that's the first equation. That's the first part of the warm-up. Now remember what we've been doing in class. Every time we have the two equations, we have one without fractions and one with fractions. Now, this one led to a fraction in the answer, but that one, number 2, is actually starting with 1. So we're going to do that. All right? All right, so again, if you need to see this again, just once it's posted on Classroom, rewind it, pause it, whatever you need to do to get it down. I'm going to do number 2 now. And I'll zoom in again in case you guys didn't get a chance to see it in the beginning, okay? Number 2 is right there. We're going to look at 1,290 equals a tenth of x plus a fifth of x. Let me do that one right now. Okay. Okay, once again, we're going to do this 2 times. We're going to do it with 2 different strategies. You pick the one that you like the best. In class, you guys seemed to like clearing the denominator, so we're going to do that. And in order to clear the denominator, I need to decide which number will help me get rid of both the 10 and the 5. So what number do you think? What do I have to multiply by, and I'll get rid of the 10 and the 5 once I multiply by it? Hopefully you're telling me 10. If it's not the only one that will work, but it is the one that will keep things simplistic, okay? We don't want to make it too arduous here, all right? So here, we're going to multiply everything by 10. Now, if I multiply everything by 10, 10 times 1,290. That should get 12,900. Ivan, what do you mean 2? You wanted to multiply everything by 2? When you're trying to decide what number to multiply everything by, I want you to think about what these numbers, the 10 and the 5, would go into, not what goes into them. 10 goes into 10 and 5 goes into 10. Okay, got it. All right, so 10 times 1,290 is 12,900. All right, equals. Now, you can look at this a couple of different ways. And I guess I'll do it the long way first. 10 times x is 10x, right? And 10 times x again is 10x. But this is the part that's important, because what's happening here? 10 divided by 10 is just 1. So you're left with x. And you don't have to always write that step down. When you're comfortable with this step, you can just go straight from here to here, right? Okay. 10 divided by 5 is 2, so maybe this is what you were thinking about. I'm not sure. There's your 2x. And now there's no fraction to work with. There might be a fraction in the answer. All right, I don't know yet. But at least you don't have to work with a fraction when you're moving stuff around. All right, so let's simplify. Now, I want to point something out that I think we might have been missing in class a couple of times. Take a look at this right here. Right there, there's an opportunity to make your life a little bit easier. Okay, why not 2? Hey, Jackie, glad you could join us. All right. So I wanna answer your question. Just let me put you in here. Okay. So this is a comma. Comma, comma, comma. Not decimals. 1,290, 12,900, and 12,900. Okay. That's what you were asking about, right? Okay, now Jacqueline, your question. Okay. I can get rid of them if they're bothering you. They don't have to be there. Why not 2? Okay, what would happen if instead of doing this by 10, we did it by 2, right? Because you guys were suggesting, let's multiply everything by 2. So let's do that. But let's do it over here so we don't lose our work. Okay, come over here. And if I multiply everything by 2, okay, 1,290, so what would that be if I multiply that by 2? Let's multiply everything by 2 now. Guys, we get 2,000. Oh, I said I wasn't going to use the commas anymore, right? Because it's confusing you guys. Okay, so 2,580. Okay, then it would be 2x over 10 plus 2x over 5. And this is why we're not going to use 2. Because did I get rid of my denominator? No. I didn't. I didn't get rid of the denominator, and the first strategy, the whole point of the first strategy is to clear the denominator. This will actually help you with the second strategy though. So I'm going to leave this here and go back to it. I hope that answered your question. If it didn't answer your question, just let me know. But hopefully you see that on this side, I don't have a fraction anymore, but on this side, I still have a fraction. And the second strategy is to go ahead and just add the fractions. That is the second strategy, so we'll go back to that. Now back over here. If over here, we have an opportunity to do this, combine like terms. That's what we say usually in math when we have the bases are the same like this. We're just going to work with the coefficients. So 12,900 equals 3x. Okay, what's the next step? What's the next step? Hopefully you're thinking divided by 3. And if you do that, x equals 4,300. How did you clear the denominator? I missed it. For stuff that you miss, I'm going to ask that you look back at the video when I post it, but I'm going to answer your question anyway, because it's still up here. We cleared the denominator by multiplying everything by 10. Ten times 1,290, 10 times this expression right here, 10 times this expression right here. And then 10 divided by 10 was 1, 10 divided by 5 is 2. $12,900 divided by 3 is 4,300. Okay, now that one is solved. But I told you that you didn't have to clear the denominator. You can actually work with the fractions. So let's go back to that. You guys said, why don't we just multiply everything by 2? Now, I'm going to put that back to 1,290. We have 1/10 x plus 1/5 x. Okay. Okay. Now this is where the multiplying by 2 over 2 is going to help you. In order to add the fractions, the denominators have to be the same. So we're going to keep the side the same. And if you multiply this whole thing right here by 2 over 2, this side will stay the same. 2 times 1 is 2, and 2 times 5 is 10. Okay, now the denominators are the same, and I can go ahead. Where did I get the 3 from? Where do you see 3? Oh, over here? Okay, let me go back to that. This is a different strategy now. All right? Same denominators, which means I can actually just add them, right? Okay, and I said I wasn't going to use those silly commas anymore. Okay. 1 and 2 is 3, so 3/10 x. Now, what's my next step? In class, you guys have been telling me the next step is to divide by the 3/10. What is the same as dividing by 3/10 here? Multiplying by the reciprocal, right? So if I multiply by 10 over 3 to this side and 10 over 3 to this side, this becomes x equals, and you should get the same answer because this is exactly what we did over here. We multiplied by 10 and then we divided by 3. Now I'm gonna come back over here because someone is asking, where did I get the 3 from, right? Okay. Where did I get the 3 from? Over here, this is 1. This is 1x and this is 2x. 1 plus 2 is 3. And I have to do the inverse. If I'm trying to find out what x is, I have to do the inverse. So 3 divided by 3 is 1. And 12,900 divided by 3 is 4,300. Do you guys have any questions on either one of the strategies? This was strategy 1, clearing the denominator. This was the first strategy, clear the denominator. And then this was strategy number 2, where we just simply added the fractions. It really, what differentiates your strategy is how you start. It's just about how you start, how you choose to start solving an equation. So add the fractions. Okay. If you guys have any other questions, you can comment. Let's see. It says on the second one. What does that mean? Where you get the 3 on the second one. So are you referring to this 3 right here? If you're referring to this 3 right here, I get it from the same spot I got it from the other one. 1 plus 2 is 3. Okay, yeah. So over here, when you want to add the fractions and you need the same denominator, I have to multiply this one by 2 over 2. 2 times 1 is 2, and 2 times 5 is 10. But then because these are the same base, again, I can combine like terms. So 1 plus 2 is 3, and the denominator stays the same. Our whole stayed the same. It didn't change. All right? You guys have any other questions? Any other questions? That was a very long warm-up. But that's okay, as long as you're learning. That's the whole point of this. Okay, we're going to move on. And I have a little note here that we're going to do a recap on exponent rules. Okay, so I'm going to take you back just a tiny bit. Because by doing that, I think it's going to help you with today's tasks. Our tasks today are going to apply the rules that we've learned with exponents. It's going to apply to scientific notation, which was it's so silly, but thank you. Okay, let's go back to exponents, right? Tell me what to do if I have, how do I simplify? If I have 10 to the second power and I want to multiply it by 10 to the third, what do my rules of exponents tell me to do? They're the same base, so check. So what am I allowed to do? You guys remember? I hope you do. And actually, honestly, if you forgot, you could just expand it and then you can still figure it out. That's right, we add the exponents. So that means by Dagny's idea, if we added it, it simplifies to 10 to the 5th power. Now, if you completely forgot, you could just expand this. 10 squared is 10 times 10, and 10 cubed is 10 times 10 times 10. So how many do I have altogether? I have 5 of them. So even if you forgot, you can still figure it out. Okay, let's do another one that you're going to use today. You're going to use this one. And how about this? Let's go the opposite a little bit. What if I started with 10 to the 5th and I wanted to divide it by 10 to the 2nd power? What would I do with that? Same base, so I'm okay. I can apply the rule. And again, if you don't remember the rule, expand it. That's right, I'm going to subtract them. So 10 and then 5 minus 2 is cubed. So 10 cubed. Nice job. For those of you who forgot or you don't have your stuff with you to figure it out, if I have 10 to the fifth power in the numerator, and I have 10 squared in the denominator, think back to your charts. The charts that you were filling out in class a while ago, we would match them up. 10 divided by 10 is 1. 10 divided by 10 is 1. So what are you left with? In the numerator, you're left with 10 cubed. Okay, so that's the recap. That's really important for today's tasks. I need you guys, if you have your books, please go to lesson 14. You can, for now, you can turn to activity 4. Don't turn to activity 1 yet, because I want to show you one at a time. If you don't have your book, it's okay. You can use the website, like I was telling Elijah earlier. And then just make sure you have something to write with, okay, so that there's work in your books. Okay, so the first one, you're going to decide if the equation is true or false. Okay, ready? And no peeking. Don't peek. Wait, don't go to the page yet. It's okay. I'll tell you when we get to activity 4. I want you to decide if this is true or false. If I have 4 times 10 to the 5th power, and I want to multiply it, I'll just do the x again. If I want to multiply it by 4 times 10 to the 4th power, is the answer going to be 4 times 10 to the 20th? And I'll zoom in for you guys. I want you to decide, is that true or false? True or false? What do you think? I hear false from at least one person. Okay, why? Why is it false? Thais says it's true. Okay, so I hope you guys can back that up. Why is it false? Why is it true? And I'll even here, true or false? Which one? Because you're adding, we're adding. Okay. So if we have the same base, right, just like we had over here, we should be adding 5 plus 4. What did they do? They actually multiplied. They did 5 times 4 is 20. That's incorrect. So this particular one is definitely false, based on what Ivan just said. You're supposed to add the exponents. So 5 plus 4 is 9. It is not 20, which means it's false. So I'm just going to put a slash through that so that everybody who's looking at it afterwards, they know this is not equal to. This is definitely false. Good job. Okay, second one. If we had 7 times 10 to the 6th power, and I wanted to divide it by 2 times 10 to the 4th power, would it be equal to 7 divided by 2 times 10 to the 6 minus 4? Oops. Made that a little too big. And I'll zoom in again for you so you guys can decide. Be nice. All right. 7 times 10 to the 6th power divided by 2 times 10 to the 4th, does it equal 7 divided by 2 quantity times 10 to the 6 minus 4? Is that a true statement or a false statement? What do you guys think? False? False? Why is that false? Tell me why. Oh, okay, you said we have to subtract the exponent. So did they subtract the exponents here? Same base. Are they subtracting the exponents here? 6 minus 4? Looks like they're subtracting. So if we're supposed to subtract and they're subtracting, why would you say false? So over here, you guys told me that when you have the same base, you subtract the exponents. Same base, 10 and 10, 6 minus 4, and that's what they wrote down here. I just erased it by accident. Okay, now, something that we really didn't talk about in class is that you can work with the numerical factors or the coefficients separate from the bases, and that's what they did here. 7 divided by 2, literally 7 divided by 2 is right there, and then over here, 10 to the 6 minus 4. Well, what's 6 minus 4? 6 minus 4 is 2, right? All right, so this is true, guys. This one is true. 7 divided by 2, 7 divided by 2. 10 to the 6th divided by 10 to the 4th is 10 to the 6th, take away 4. This is true. How? I just explained it. I'll do it again. So over here, this part goes with this part, 7 divided by 2. This part goes with this part. 10 to the 6 minus 4. They didn't simplify it. We didn't ask you to say what is the simplest form. We just wanted you to take a look at it and decide, is the left side equal to the right side? And right now it is. It's still the same thing. It's just not simplified. I wonder if it was written like this. If you guys would have liked that better, how about this? How about that? True or false? Is 7 divided by 2 3.5? Is 10 to the 6th power divided by 10 to the 4th 10 squared? True or false? Adrian, this is an eighth grade stream. It's okay. Don't worry about it. Look at the one on Classroom for 6th grade. I did you guys from 9 to 10. I did it. Or you can show your sister because she's in this class. That would work. Okay, so 8th grade, what do you guys think? That last one that I wrote, do you like that format better? Is that true or false? Hopefully you say that this is true. All right, I got one more for you before we go to 14.4, okay? One more. So I am going to erase these. Okay, true or false? 8.4 times 10 cubed times 2, is that equal to 8.4 times 2 times 10 to the 3 times 2? This one's kind of easy for you guys. True or false? .4 times 10 cubed times 2, is that equal to 8.4 times 2 times 10 to the 3 times 2? True or false? All right, Ivan, why is it false, buddy? And don't say because it is. Why is it false? This part's okay, right? But they did something wrong here. There's no other base 10 over here. Thais, it's actually false, dear. It's actually false because over here is the issue. There is no other base 10 or 10 squared. False because it's false? Okay. If they got rid of this part and they just said 10 cubed, this would be okay. That would be true. But because they went ahead and they put more stuff there, the multiply by 2, that was totally incorrect. Not only that, but if I had another base 10 here, you would have been required to add the exponents, not multiply them. All right? Okay. Now for the heavy lifting. Now I need you guys to go to task 4, lesson 14, and it's on page 107. It's called Professions in the United States. Professions in the United States. It looks just like this. There's a whole big chart, and before we get started, I want to make sure that you understand the chart. In the chart on the left, they give you the name of the profession. So they're basically telling you what is the job. And for the first one, it says architect. But then for the middle column, right here, where it says number, that's the number of people in the profession. So if you were to count all the architects, it would be that number. This last column is their actual salaries. What are they making per year? So we're going to, if you turn the page, we are going to answer number 1, 2, and 4. We're going to skip 3 to save some time, because it's really redundant anyway. Number 1, 2, and 4. And the key word there, I circled the key word. Key word there is to estimate. We're not going to get an exact number, when we answer these questions, we're going to actually just estimate. We're going to answer them based on the chart. So number one says estimate how many times more nurses there are than doctors. Okay, so I want you to take a look at nurses and doctors. How many times more nurses are there? Okay, perfect. Thank you, Adrian. Let's take a look at doctors. And let's take a look at nurses. All right. Okay, that'll be easier for us later. So if you take a look at the nurses and the doctors, which column do we have to look at? They want to know how many more nurses there are than doctors. What column are we looking at? The middle or the last? They didn't say anything about how much they make yet. They're just talking about the numbers. They want to know how many more nurses are there than doctors. That's right, the middle. Thais, try refreshing. I might have to type that out. I circled the ones that we're going to look at. Dagny, you said the middle number. We're going to take a look at those two middle numbers. And we're going to estimate. We're going to estimate how many times more the nurses are than the doctors. Hi, Harmony. Glad you could join us. We are on page 107. We just started activity 4. And we're going to try to estimate how many more nurses there are than doctors. Okay, what's the first thing that you notice when you're trying to compare those two numbers? It's the very first thing that you're going to notice. Okay, it went back to normal. Perfect. Elijah. There's decimals. Okay. What else do we notice about that? It's okay. You can, I'm going to post it on Google Classroom. You'll be able to see it from the beginning. We're on page 107, activity 4 in lesson 14. The exponents. Okay, Dagny, what specifically about the exponents did you notice? What specifically do you notice about those exponents? One has the 5 and one has the 6. Okay, good. What about the bases? Are the bases the same? Yes, the bases are the same. So we know that nurses, there are definitely more nurses because it's times 10 to the 6th power. They're both in scientific notation. Okay, good. They're both in scientific notation. Nurses are way more because it's 10 to the 6th power. Doctors are 10 to the 5th power. All right, now, what if I asked you How many more, instead of nurses and doctors, what if I said to you, how many times more is 8 than 4? How many times more than this is it? Isn't 8 2 times more than 4? Right? Sort of, yeah. School spirit. Good morning, Sanaya, or afternoon, good afternoon. 4 times. Okay, 2 times, yes, 2 times. 4 times 2 would give me 8. Now, the other way when you have the high numbers or you have scientific notation, it's not as obvious. So what's another way to figure out what that number would have been? What's the other way I can get that 2? What can I do with these 2 and I'll still get that one? It's okay. Exactly, divide. Nice job, kiddo. Sanaya saying we could divide. If I do 8 divided by 4, I'm still going to get 2. So we're going to apply that now because these scientific numbers, the scientific notation, these numbers are not that user-friendly, right? 8 and 4 and 2, that's really nice, that's simple, but scientific notation gets a little tricky. So if the nurses are the higher number, we're looking at 3.45 times 10 to the 6th, and if I want to know how many times larger, I would divide it by the doctors, 6.9 times 10 to the 5th. Now, they said to estimate, right? They said all we had to do was estimate. So give me some ideas about how we would estimate what this could be. Don't use your calculator. Let's talk about estimating and doing this without a calculator. Well, what's 3.45 close to? Isn't 3.45 close to 3.5? And what's 6.9 close to? Isn't it close to 7? Okay. That's a little nicer, right? Okay, I'm glad you agree with me. Now, you guys already told me from our recap, I'm going to end up subtracting these exponents. So the result, 6 minus 5 is just 1. I hope you guys can see this. Six minus 5 is 1. So now I just have to worry about this part right here. 3.5 out of 7. Well, isn't this number half of this number? This number is half of this number, so I have a half. And over here, I applied my rules, 10 to the first power. Well, what is this number times 10? Isn't it just 5? So we can say that there are approximately 5 times as many nurses as there are doctors. 5 times as many. So if you take the amount of doctors and you multiply it by 5, you're going to get roughly, approximately, the number of nurses. I hope that makes sense. Where did we get 7 from? Tell me where we got 7 from, because the answer is 5 times as many. Okay, it does make sense. Okay, cool. And you see how we did that without a calculator? And it's not because I'm a math teacher. It's because you applied your exponent rules, and it's because you knew that this number estimated to this number, this one estimated to this one, and that 3.5 is half of 7. Wait, what page are we on? Page 107. Page 107 in your workbook, please. There's a chart, and then the questions are on the back, actually. So only the chart is on page 107. The questions are actually on page 108. Okay, so we have 2 more questions that we're going to answer on here. We're going to do number 2, because for number 2, look at what it says now. For number 2, we're not talking about how many nurses and doctors there are anymore. We're talking about how much they make. And remember that how much they make is actually in the last column. Now, no problem. Now, I'm going to get rid of this for a second. And remember, it's going to be posted on Classroom, so if you missed anything, you just watch it later and jot it down, okay? Pause it, rewind it, whatever you want. Okay. Now, if I told you that there were 5 doctors and they each made only, I'm going to make something up really ridiculous just so that it's easy for us and then we apply it. If there were only 5 doctors and they each made $20 a year, that's their salary, how much do they all make all together? How much do all the doctors make all together? Page 1, oh, okay, no, that's okay. You got it. Well, hopefully you guys tell me that they all make together. Okay, you want, okay, the question? Okay. If I told you that there were 5 doctors and they each made $20 a year, how much would they all make all together? Hopefully you tell me that their total, that's $100 combined, right? Because each doctor is only making 20, 40, oh, yes, 100, good job. Yep, 100. Now we're going to apply, what did you do? You just did 5 times 20, right? We're going to do the same thing here. There are 6.9 times 10 to the 5th doctors. That's how many doctors there are according to the chart on page 107. And they each make 1.87 times 10 to the 5th. And if you wanted to know how real it is, in the top corner, it says that it's as of 2012. So it's kind of old. Kind of old, but, you know. Okay, now, you said just multiply them, right? You said 5 times 20 is 100. So that means if we multiply these two, we're going to be able to answer how much all the doctors make. Well, remember, what was the key word? What was the key word in all of these questions? Somebody type it for me. What was the key word? It was to estimate, right? I circled it for you. It's to estimate. So what do we estimate 6.9 to? That could estimate to 7. What is 1.82 and 1.87 estimate to? That's right, to 2. Now you guys already told me from the warm-up, if I have the same base and I'm going to multiply these, I add the exponents. So 7 times 2 is 14, and then 10 to the 10th power. Do you guys know what this is? Like thousands, billions, millions, trillions, like what is that? So all the doctors combined make about billion. About 100, it's about $140 billion combined. Any questions? Same thing. It doesn't make any sense? No questions, you mean? Okay, no questions. Okay, that means we're going to do number 4. And then you're going to do 2 things for me for homework. On Google Classroom, I posted Lesson 13's cooldown because it's a review of scientific notation, making sure that you can go back and forth like your quiz. So easy A. The second thing you're going to do for me is your practice problem from lesson 14, only number 1. Only number 1. All right, charge it, Ivan, charge it. Okay. Number 4 is basically 2 questions in 1. Who makes more? And then how many times more? So I need you guys to go back into your chart and take a look at military, enlisted, and officer. So who makes more money? And be careful because it says all of them put together. Thais, the homework is practice problem number 1 for lesson 14. And on Google Classroom, there is an assignment. Yes, practice problem number 1. Okay, let's take a look at enlisted. We would have to multiply to find out all together. That is 1.16 times 10 to the 6. We have to multiply that by 4.38 times 10 to the 4th power. And that's for enlisted. So what is that? If we were going to estimate, you could estimate it to 1 times 10 to the 6th and 4 times 10 to the 4th. What's 1 times 4? Same base, add the exponents. Okay, that's the total for enlisted. Total money for enlisted. Okay, now let's take a look at the officer. We have to multiply those 2 numbers together now. So that's 2.5 times 10 to the 5th times 1 times 10 to the 5th. 2.5 times, now this is nice because it's already basically estimated for you. 2.5 times 1 is 2.5 times 10 to the 5 plus 5. Now they're both the same exponent.
talk about convenient, because if you know that this one is more and this is the officers, now we're going to actually answer the question, how many times more? Ten minus 10 is 0. Anything to the 0 power is? Elijah, stop messing around. Anything to the 0 power is? It's 1. Anything to the 0 power is 1. So this right here, that's actually 1. Now let's estimate. If you estimate that to 2, 4 divided by 2 is 2. So how much more? About 2 times more. About 2 times more. Now, let me make sure that, okay, so I'll zoom in on your assignment. Lesson, only number 1 for the practice problems, and then it was unit 7, lesson 13. There's an exit ticket online. And unless you have any other questions, we're done. Here's your homework. Number 1, lesson 14, practice problems, and unit 7, lesson 13, it's on Google Classroom. You guys have any last questions for me? Maybe on anything from Moby, from corrections? You don't have to do Edulastic yet. I extended it, and we'll work on that when we do test review. All right, then you guys have a good rest of your day. I'll stream again tomorrow for the next part of your lesson. Make sure you get your work done. Make sure that you're looking at your Google Classrooms throughout the day, and that you're keeping up with your work, okay? Don't let it go behind. All right, stay safe. Test review, we are scheduled to do that. Test review. We are scheduled to do test review Thursday and Friday right now. All right. Good question, Kira. All right, guys. Till next time. Stay safe.